Okay, can we have, let's go, Abby, Luke, Chloe and Elijah Wegler. Alright, and I'll ask some questions to your teacher. Just squeeze this through. Can you bring your whiteboard now? Alright. Can you stand over this way? Okay, that way. Jump. Over there, Luke. And then Chloe, can you stand against the whiteboard a bit more so next to Elijah so that those people over there can still see as well? Hold on. So, Abby, what did your team start to do and realise here?
We started to list down like the twos at the bottoms and like all different numbers around it.
Okay, so the first row, Elijah has what at the bottom?
Has the equal number 2 that's even.
The number 2 that is even at the bottom. And how many examples did you have with 2 at the bottom?
3.
3 examples. Why? Hold on. Well, let's see. Elijah, why do you have 3 examples with 2?
Because we were seeing like with the 5 1, 5 3, or like 5 4.
Oh, okay.
We're seeing if we could if it would work, but it didn't.
Okay, hold on. Cool. All right, hold on a second. Elijah, you were explaining that pretty well. 5 and 1, 5 and 3, and 5 and 4. So, as a group, why have they done 5 and 1, 5 and 3, and 5 and 4 on the arms? Go, turn and talk. Three, two, one. Hunter, why do you think that they've then done 5 and 1, 5 and 3, and 5 and 4?
Because if you look on here, everyone's only done those numbers.
So they've done different, they are the only different combinations of the numbers. Because here, if I then put 2 down the bottom, I have to test 5 and 4, 5 and 3, and 5 and 1. They're the 3 different combinations on one arm that we can have. Do you have something to add on?
Why didn't you do 5 and 2?
Okay. Chloe, why didn't you try 5 and 2, I suppose, in this example?
Because you need to keep the 2 at the bottom, because it's the even number. If we switch 5 down, it would be an odd number.
But 4 is also an even number.
It is. So, good. So this row, Vincent, what have you guys done in this row, Abby?
That one we just tested with the 2 on the bottom.
Very good question. So you were leading to our next point, Vincent. So then they've tested with the 2 on the bottom, and they've tried all the different combinations with the arms. But then, for example, here, so see how they've got 1, 4, and 2. What could we have done with 4 and 1? Just move. That's right. Move back a second. Then, Jai, what could we have done with 4 and 1?
I want to talk about the 5 and 1.
The 5 and 1 here.
No, on the 4.
Is this to do with what your idea was?
Yeah.
Cool. All right. I'll bring you up for your idea in a second. Okay. So Luke, do you want to explain to people? So what we're saying here is we've got the same combination on this arm. I could have 1 + 4 + 2. Okay, and it would still be a different V. Like, Luke, do you want to explain why you knew not to just test more?
Yeah, so if we did 4, so if we swap those 2 around, did 4, 1 and 2, and then 5, 3, 2, it would be the exact same outcome because 1 + 4 + 2 is 7 and 4 + 1 + 2 is 7 as well. So you know that you don't need to try all those examples because it will be the same outcome, and you could rather just do those 3 examples where each goes with one of each numbers rather than doing like how much it ever was. Yeah.
Okay, so what Luke is saying, can you actually turn and tell people around you what's Luke saying? What is Luke saying? Three, two, one. Will, what was Luke just saying?
So he was talking about like if you've got one example, then he doesn't have to keep doing it again and again. He can just
Yep, so that's right. Does everyone want to add on to what Will just said about what Luke is saying, Sarah?
Even if you switch the two numbers at the top, you're still going to be adding the same numbers together.
Good, perfect. That's a really good way to put it. What Luke was saying, what Sarah's just added on, and Will, you were saying the same kind of thing too, is even though I've got 1, 4, and 2 on this arm, I'm still adding the same 3 numbers together if I swap the
4 and 1 around.
the order of the 4 and the 1. So here, see this example 1, 4, and 2. Over here, I've got 4, 1, and 2. Right, so it's still the same numbers added together, just in a different order. That arm is still the same. And then here, so once they've tried the 2 and they thought, okay, well now I've got all the different combinations with the 2, they then tried what number next on the bottom liner? The 4. Good. Why'd they try 4 on the bottom liner? It was the other even number. Yeah, good girl, good job. And they did the same kind of thing. They only needed how many different examples for the 4? 3 different examples, but altogether, how many different combinations would there be with the 4 on the bottom? 6. Well done. Good job. So this was a very systematic way. This was a very efficient way to do it. They had a system. They tried one number on the bottom, another number on the bottom, and then didn't need to try all cases. Good. Thank you very much. Right, so one more. Oh, yes.
Can I just want to add, this is not important for you to remember, it's just a point of interest. So when you guys have talked about proof, yeah, the idea of proving something is true, that's what we're trying to do, prove that, it's Louise, isn't it? Louise is right or wrong. So they proved Louise is right, and they've done it in a special way. One of the ways that you can test something is true is you try every single case, which is what they did. Yeah, they didn't do every single case, but they showed a way that the 6 cases that they did represented every single case. Sometimes you can do that in a proof. In this case, in this problem, you could. That's a way that you can prove by every single case. Most of the time we need a different type of proof where we have some sort of special reason to prove our example, but good work finding the proof by exhaustion, it's called.
Right, and I'm just going to very quickly Jai and Jaga. That group there, especially what I really liked about that group was how every person in that group, you could tell that that group had spoken to each other and knew that every person was on the same kind of page is what we call it, and that we really tried to explain it well. So that group there, really impressed with that teamwork and collaboration. Alright, Jai. Good. Okay, hold on, we're just going to move it this way a little bit more. You can use the whiteboard if you need to. Jacob, why don't you start by telling us what you...
Okay, so the first thing we found out is that when we're putting the even numbers in, we kind of figured out the same thing as Luke's group, how no matter if you switch them around, they'd still equal the same thing.
Yeah.
And then we started to look at the numbers, and we figured that if you wanted to get it to work, you would have to have numbers that has a one difference. So
Okay, so just move your body a little bit. So what do you mean by one difference?
it's like a difference of 1, because there's 4 is 1 away from 5.
4 is 1 away from 5.
And we'll do 3 and 2, but that means that takes out all of the even numbers, so we have to
Oh, it takes out all of the even
so we
numbers.
put the even numbers there.
Okay, you put an odd number down the bottom, so you couldn't put an even number at the bottom here. Jai, do you want to add on to that explanation at all? Like, what do you agree with what Jaga's just said?
Yeah, but what we've really found out is...
Hold on, with that, so you agree with the difference here. Jake, can you just,
Yeah.
I don't think Will and Cooper can see. That's alright.
So we said that,
With the difference, can you explain that any more? Because
yeah, it doesn't work because 4 and 5, they're 1 apart, so that's why it works like that.
okay, yeah, and then
3
what?
and 2, they're one apart.
But how many? So this side here, what's important about like 4 and 3 here? Can they be? So can that be 1 less and that be 1 less?
No, yes, it can.
So this side can be 1 less than 5 and 1 less than 2.
Oh no, yes, it can be, but it can't be. If it's 2 less, if so, this was 1. And
Is
this
3 1 less or
4
1
and-
more than 2?
4 and 3 is 1.
Oh, one. Oh, it's 1
and 2 isn't.
Oh, it isn't.
Yeah,
good.
so
Good
there's
point.
1 more than 2,
When-
not 1 less. Like,
Like,
yeah.
oh, look, are you okay? Do you want to explain kind of what?
oh, so yeah, that's what I'm trying to say.
Yeah, yeah.
Your 5 and 4, you're saying that it's a difference of 1, and that it's 1 less than the 5, but 3 is the 1 more.
Yes.
Good.
So
So then it does what to the sides?
So it balances out. So 4
no, 5 is bigger than 4, and so then that means this side's got one bigger number.
Good boy.
And
Yeah.
3 and 2, this side's got a bigger number. So they've both got one bigger number on each side. That which means it balances.
No, wait. Hold on there. Good explanation. Sarah, do you have something?
So like it's because the 3 is bigger than the 2. It's kind of like the split part, but like if you take 1 off 3 and add it to the 4, it's 5 and 2. Same as the
Yes.
other side,
Okay, good.
and then
Good
you're adding
job.
the 1 to both of the sides. So
But then if you do an even number, and then there's gonna be one number. There's gonna be one bit where it's 2 apart.
or even more.
So it makes it's unbalanced.
Unbalanced.
Because then if
Yes.
yeah, you can
Hunter.
you
Yeah.
can see
You can see how that one's balanced.
So if you look at it as 1B,
Yeah.
it's
1 second, sorry. Just listen to him say yeah.
instead of the cross, you can see 4 and 3 are like there, but 2 and 5 that's like odd because 2 and 5 are
2 and 2 plus 5.
not 2 and 5 are just
So they
like,
equal a what though? 2 plus 5 equals an odd number. And 2 is an even number, and 5 is an odd number. So an odd plus an even equals what? An odd number. And then we've got the same on the other side, don't we? 4 and 3. 4 is an even number,
and then
3 is an odd number, and that also equals an odd number.
So what we're kind of trying to do.
Oh yeah, okay,
So
last.
we found that these two
second.
here, we
Yeah.
found that these 2 here, they're 1 apart, but then if we put an even number down there, that means the 3 will be 2 apart from the 1.
3 will be 2 apart from the 1. Good, so it's now what?
It now becomes unbalanced.
Unbalanced.
And so, but what we're trying to do is we're trying to do least amount of examples and more explanation to make it so it's like we don't have to do loads of answers to figure out the answer.
Good, I like
We
it.
don't
So,
have to do loads
yeah.
of combination like Luke's team did. We just have to find one thing that makes it that works for every single one. So it just makes
Good,
sense.
and you really started to then what we would say like analyze why does that work. So rather than finding lots of different examples, we'd have really studied one example in particular.
yeah to find out.
Good job. All right, Luke, I'll chat to you about your idea afterwards.
I want to talk to that thing just quickly, just really quickly.
Go then.
Just a question. So you were saying that you didn't try you tried just like a couple examples.
Yeah, we
And
tried
then-
one for each one.
Yeah, but you just saying that you actually kind of had to try all the examples because what happens if you didn't try all the examples, but actually there was an example where it was there could be an even number at the bottom for it to make it work. That's what I'm trying to say. That you didn't try. You should have tried all the examples just to make sure.
But then
No,
we're
I'm not-
saying
Hold on. Okay, hold on. No, this is a really good. Hold on, Jacob. This is a really good point, and I'd be intrigued about the answer. So Luke is saying that you do need to try them to know that you've got them all.
But there's
Sarah,
no point because
hold on,
it's
boys.
just switching them
hold on,
around.
boys. Sarah, what do you think?
I think Luke's right, but then like also their team was also right but you need to make sure that you know the right answer before you can start coming up with ways to like
Okay, so I'm gonna
find it,
stop you
so
boys
you
there.
can know if your strategy works for all of them or if it
Very good. So you're saying if hold on, Jai. You're saying that if we can get a strategy that works for all of them, or something like a rule or a pattern that works for them all, do we need to try them all?
No,
but how
All right, Jai, Jacob, sit down quickly.
I'm talking about how I had three fours with the 5 going with each number, and the 2s at the bottom with the 5 going in each number. I'm not talking about swapping the 2 and the 1 around. I'm talking about the actual examples like that.
All right, this is a very good example of a respectful debate.